Eric Burgess here. At a dog show, 8 dogs line up. How many ways can they do this? If they form a circle, how many ways can they do that? Assume relative position doesn't matter. So let's look at this first bit. The assume relative position doesn't matter stuff, that's for this circle. You'll see what that has to do with here in a second. So at a dog show, we have 8 dogs, they line up. Beautiful. So we've got 8 dogs. So let's say we put our first dog here, and then our 7th, 6th, 5th, 4th, 3rd, 2nd, and 1st. So we had 8 dogs. We put one of them here. So there were 8 possibilities. That's why the number 8 is here. And then we used one of our dogs. So now there's only 7 dogs left. So any one of the 7 dogs could go in this spot, and then any one of the 6, and so on and so forth. And by the fundamental counting rule, we multiply all of these, and we are going to get our answers. So this is the same thing as just 8 factorial. So in the calculator, you're just going to hit 8. And if you have one of these calculators, you go to the math key, and then you go over to the probability menu. And then you see on number 4, there is a factorial key. So you go ahead, you select that, you hit enter, and you get out 40,320 ways. Now we're told, well, the dogs, they line up in a circle now. So we would have, let's just say that our 8 dogs, we have 8 possibilities to place a dog at the first point in our circle. And then we have 7 left, 6, 5, 4, 3, 2, 1. So here's our circle. And this becomes important for the second bit. Does relative position matter? Now, most texts don't include this. They just want you to assume that it doesn't matter, which is kind of makes the problems, I think, a lot more tricky if it's your first time seeing a question like this. So relative position is the name of the game. When we say relative position, it's saying what if all the dogs moved over a single spot in the circle? So now the dog at spot 1 is now at the top, and then we have 8, 7, 6, 5, 4, 3, 2, 1. So if we had something like this, well, what's interesting here is that look at 8. 8 has the neighbors 7 and 1, and over here 8 has the neighbors 7 and 1. So if relative position doesn't matter, then this is the same thing as this. Because, they're in a circle. And so this is generally why the circle question's brought up next. And so in this case, if we say these are the same, then that means that we have to pick a reference. And then, because we could swap 1 and 7, and that would be a unique order. We could swap 7 and 2. And what we've essentially done is it's like we've cut the circle at our reference. So here's our reference, and we cut the circle here. And now it's like a line going from 7 to 1. It's like 7 times 6 times 5 times 4 times 3 times 2 times 1. It's like a line happens where any one of these could swap places, but it's all relative to the number 8. We could have picked any number to be the relative spot. There would still be 7 spots remaining. And so when you're given a circle, in general, if the relative position doesn't matter, then we would say, okay, this is just going to be 7 factorial. It's going to be 1 less factorial. So we do 7, we go to math, do our probability, factorial, or you could type this all out. It's not too bad. And we get out 5,040 ways for a circle. So there you go. There are how you do a question like this. Oftentimes the circle one's sort of tossed on there to see if they can get you with some fancy relative position jargon. And again, this isn't there, but as soon as you see something like any sort of a closed path, you need to ask yourself, okay, well, things could be relative to other points on the same path. So we need to be careful about this and decide whether or not it really matters. For most stats classes, it's going to be the circle one's going to be specifically angled to point this out, and it's going to be 1 less factorial. If you have any questions about this, feel free to let me know down in the comments. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.